I'm Linus Håkansson. I'm the VP of Product here at Gravitee. And what I will be talking you through today is first and foremost the definition of API gateways and how API gateway sits in what is called the full lifecycle management. We'll then talk to some of the trends that Gartner are seeing in the API space, and as well their recommendations in terms of end users making decisions and following along on the API management implementation. We'll then have a look at how we at Gravitee have been seeing the API platforms evolving over the last couple of years and the needs from enterprises and customers evolve over the years. And then we'll introduce who Gravitee is, what we do, and the concept of event-native API management. We'll be looking at a few real-world use cases when it comes to event-driven architectures and event APIs and how something like Gravitee helps bridge the gap between those two worlds. And then we'll go into a Q&A in the end. So first and foremost, definitions. So full lifecycle API management is a term that typically covers these 5 areas of the API lifecycle. So some organizations start with designing the APIs before they implement them. Sometimes that is referred to as API design first. And this is where you have tools that allows developers, architects, or maybe even business users to participate in the design of the APIs, their specifications, their documentations, what the requirements are around those APIs. Then quite often you bring those API models and the designs into maybe a testing suite so that you can actually run maybe mock responses and examples requests based on those designed APIs, maybe even before you write a single line of code. So as part of full lifecycle API management, you typically have some testing, whether it's tracing, debugging, or other type of measures to try the APIs before they go live and after they go live. Then, of course, the API gateway is a very critical component of the full lifecycle management. It's the actual data plane and runtime that protects upstream services, whether it's a REST API, a SOAP API, a GraphQL API, whether it's a microservice API or a monolith API, whatever it might be, you typically have some type of proxy and runtime sitting ahead and behind of those different services. What is very common in the full lifecycle management is also some type of portal and cataloging capabilities so that your end users, whether they are internal developers, internal consumers, external developers or consumers, have the ability to understand and view what type of APIs and services are available, having the ability to comment on them, socialize around them, receive access permissions to different APIs, and then obviously get the documentation to understand how they are supposed to access and run APIs. Another critical component is versioning and retirement, other type of governance capabilities in an API lifecycle. The ability, for example, to deprecate APIs, to publish APIs, to write contracts between an API consumer and an API producer, provide SLAs, maybe monetization, and then allow your consumers to be safe in terms of audit and alerting and other types of capabilities to ensure that they are on the right versions, that get notified if there's a change, and so forth. One of the key concepts that Gartner has is what is called hype cycles. So those not familiar to hype cycles, you basically have this innovation trigger, which is typically very early in the journey of a new technology. There's a lot of hype, a lot of expectation in the market. Then what typically tends to happen is that you go through this kind of peak of inflated expectations and down to the kind of through of disillusionment, where you start to kind of have more expectations on actual tooling that delivers on top of those new technologies. And not always are those tools mature enough to handle the actual production use cases for those technologies. But eventually you go into the slope of enlightenment and plateau of productivity, where those tooling behind the technologies start to actually deliver on the hype and expectation of the technology. So some of the things that we will be focusing on in this particular session is, for example, event-driven APIs and graph APIs and API standards and different ways of consuming APIs. Because what you will see throughout this presentation is that the market expectations, consumer behavior has very much moved beyond just REST and SOAP APIs. And that is what we will be looking into further in this presentation. Before we do that, one big trend that Gartner is also looking at is the requirements for end users to be able to consolidate and distribute gateways and the way that different teams operate on gateways and APIs in different organizations. So if you start on the left-hand side here, you see a quite common implementation of an API gateway and API management solution where a single control plane, which typically encompasses things like a database, maybe analytics, the user interfaces, developer portal, is facilitating distribution of multiple upstream services that can run in different distributions, different cloud, different on-premise installations, but typically controlled by a single gateway in this leftmost hand case. Then what some of the API vendors provide is the ability to deploy multiple installations of an entire API management solution, which means that organizations can decide to implement API management as close to their end services as technically possible to reduce latency, to give more control and so forth. And in the middle here, we have a case where there might be multiple API management solutions implemented in an organization. So it might be different vendors that provide API management capabilities that are deployed across the organization with different control planes, different gateways, having the responsibility to protect and federate across different upstream services. On the fourth column here in this particular Gartner table, we have what is called distributed API gateways, which is starting to become quite a common way of organizations to use a federated API deployment approach. So in this particular case here, what you can see is that you have one control plane from one vendor typically, but the gateways, the runtimes that sits next to your services and protects your data might be distributed across different data centers, across a mix of public and private and on-premise distributions. The right-hand-most side is what Gartner calls federated cloud API gateways. And in this model, Gartner has identified that there's a limited support in the market for this type of installation. The concept here is that you use the runtime, so the gateway mainly, from multiple API vendors, but you use a single control plane, so a single developer portal, a single administrative interface for your teams to work in to run and manage APIs that physically runs on different vendor gateway distributions. Now, one of the things over the last couple of years that have really changed how organizations and vendors think about APIs is the explosion of different types of formats. So if you go back a couple of years, you typically talk about WSDL and SOAP envelope. Then you obviously have the introduction of the REST APIs and things like Swagger and Open API specification to help document and design what those APIs look like. But over the last couple of years, we've obviously seen an explosion in GraphQL APIs to build kind of backend for frontend type of services, or to accelerate the innovation in consumer, maybe mobile or web service applications using GraphQL. We have things like gRPC being implemented as well to further control how services are talking together in kind of different remote calls. And then you have the AsyncAPI specification that have exploded in the recent years that helps to design and document and describe APIs that are asynchronous and maybe running on an event broker or other type of event-driven architectures. So now, in this new kind of world where you have to cater and consider multiple types of API consumption models, what Gartner has created is this kind of use case comparison chart for these different API formats that I just introduced. So you can kind of see here, typically today, how some of these API specifications and types of APIs sit when it comes to if they're being used externally, whether they are being used to integrate with other applications, whether they are more tailored to microservice type of APIs, whether they are more tailored toward event type of APIs. Now, one thing I should say is that this structure here on the slide is very much evolving as some of these specifications and the implementation from customers using those implementations discover new type of use cases and so forth. So what I will be moving on to now, recommendations based on the Gartner research that Paul and other analysts at Gartner has been conducting. So in one of the researches that is called API format, REST using OpenAPI specification, GraphQL, gRPC, or AsyncAPI, that very much looks at all these new type of documentation and type of APIs around those documentations, or evolving, and how Gartner thinks that this is going to be impacting end users. So what it says here is that challenge the assumption that REST APIs are always the best approach by evaluating the different alternatives. And you really have to look at your end consumers that are consuming the APIs and understand their use cases and the tools that they're using to ensure that you're delivering the right type of APIs that makes more sense for them and might potentially be more productive and generate most revenue for you as an organization. So that is not always REST. That might be async APIs. It might be GraphQL APIs. It very much depends on the use case and the tailored consumer that is going to consume your service. There's another research from the Lifecycle that I showed you an example of in a couple of slides ago that Gartner does a couple of years, different intervals, different types of segments. Back in August, they did a Lifecycle specifically for API technologies. And some of the recommendations that they concluded was that you need to evaluate whether you're choosing API mediation products. So API mediation typically means the ability for your runtime to be able to translate and proxy different types of API architectures, so that your API gateways, as well as the rest of your API management stack, are supporting things like event-driven APIs, such as being documented by AsyncAPI, for example, and that you think about that during your selection process. And you start looking at what use cases do I have, what maybe revenue streams can I look at, what opportunities is there to replace some of my traditional REST or SOAP request response APIs with event-driven APIs to kind of help give better user experiences and build new type of revenue streams on top of what I currently have. So Paul, who unfortunately could not join this session, has been co-authoring a market guide for API gateways from Gartner that came out in the end of October last year. And one of the recommendations here is that you should assess the role that events and data grids play in the application strategy and select gateways that do have support for things like AsyncAPI and GraphQL, that you should be having a look at beyond REST and SOAP. Are there other technologies that I can be working with and taking advantage of that can help me build maybe new revenue streams or increase my consumption of my APIs? Okay, so if you're familiar with Amazon, you probably have seen the CTO session from a couple of months ago in the keynote. There was a big focus on event-driven and asynchronous being a very, very key thing for the cloud and for the technology in the next couple of years. One of the quotes was, "The world is event-driven." And it's definitely something we're seeing here at Gravitee. So what I wanted to take you through is first walking you through Postman's State of the API report from last year, where they conduct a research across API consumers and producers and other type of roles in the technology world and survey how they use technologies and what type of technologies they use. In terms of an architecture style of consuming services, REST is still the number one leader, where almost 90% of organizations are using REST. However, REST actually fell in the popularity compared to last year. Now, webhooks and GraphQL and gRPC were technologies that grew. So webhooks, WebSockets, MQTT, AMQP, server-sent events, EDA are all technologies that are asynchronous by nature. And then your REST and SOAPs are typically synchronous, and GraphQL it kind of sits somewhere in between. So what this is showing us is that there's a trend and change in mindset, basically, in terms of how people are exposing and architecting their services and APIs. To give you an idea of what that means in terms of the communication, documentation, formats of how those technologies are implemented, I wanted to give you an idea of a comparison between our traditional APIs and your new kind of event-driven asynchronous APIs. So traditional APIs are typically talking in a request-response client-server type of model. So they're typically synchronous, meaning that a client makes a request to an API or a server, and the server is then responding more or less immediately. And typically it's a point-to-point communication. So you have one client that makes a request and then gets a response that is tailored just for them. Typically you're using things like Whistle or OpenAPI or Swagger to document and design those type of APIs and architectures. And the medium of how that data is being served is typically with JSON and XML data. And some example of that is, of course, different HTTP formats like REST and SOAP. I also put GraphQL in here in parentheses. I'll come back in the next section on why I put that in parentheses, but obviously you can use things like mutations and queries in GraphQL to have this request and response type of approach between a client and a server. Now, event-driven APIs are typically slightly different. Typically, they are asynchronous, meaning that a client is typically making a request to establish a persistent connection with a server or an event broker. And typically the communication is direct, meaning that you have a persistent connection and you stream data between a consumer and a producer. And not infrequently, the communication is not point-to-point, but fan-out, meaning that if something happens on the broker/server side, it might impact multiple clients that have connected into those persistent threads. While you use OpenAPI and Swagger to document your REST APIs, you typically use Async APIs to document your event-driven architectures and your WebSockets, webhooks, and so forth. And then you quite often use cloud events to try to normalize the data formats as your async and event-driven APIs are pushing and producing data in your architectures. And while as REST sources like JSON is still quite popular in event-driven APIs, you have an explosion of things like protobuf and Avro and other formats that help serialize and deserialize data and validate data with different schema registries and so forth in the event-driven API world. So some examples of event-driven APIs include WebSockets and service and events, which is typically built into things like mobile apps or web apps when you need to stream data in different directions between a client and a server. We have the webhook technology that is typically used when organizations want to register for getting certain data in a push type of architecture, where a server will be pushing out HTTP post messages to the registered callback URLs as soon as something is changing in their upstream technologies. You have, of course, native event brokers and queuing mechanisms like Kafka, AMQP, MQTT, and so forth. And then again, I have GraphQL here under parentheses, as GraphQL has a concept of subscriptions that is actually asynchronous and allows a client to establish a persistent connection with an upstream service to retrieve changes in a GraphQL kind of syntax. So I just wanted to walk through how we at Gravitee specifically have seen the different generations of API platforms and customers' expectations and requirements in those different periods, let's say. So when API management and API platforms really came about, they came about because there was a challenge in enterprises, typically because there was an explosion of services. People were building things on top of SOA, ESB, and ETL tools, and they needed to expose them in a safe way. They needed to expose those services, maybe using traffic shaping, rate limiting. They needed to have them in a developer portal so consumers could see and understand and access those APIs. They were typically centered around REST and SOAP as the common type of technologies that were sitting on top of those services. Now, what we then started to see a couple couple of years ago was organizations had more complex requirements. And typically it came about because they started to move away from monolith applications into more microservice distributions and architectures. They started to break up their monolith applications into more lightweight components. They started to use things like containerization and Docker, maybe putting it in a Kubernetes orchestration environment. Maybe they wanted them to communicate together in the Kubernetes cluster using service meshes. They typically use more of a declarative approach, an infrastructure as code or GitOps approach to develop and version and model those services. And that really put a new set of requirements from customers on how API platforms provided tooling that helped those organizations work with APIs. And that's when you kind of had a new generation of API vendors emerging. Now, what we have seen the last couple of years here in our customer base and in the market, by speaking to analysts and obviously to end users, is that organizations have been very much embracing event-driven architectures because they want to drive more real-time decisions. They want to provide better real-time consumer experiences. Like when you order your Uber cab, for example, you want to get a very real-time experience on where your car is it turning the corner, how far off is my car? And when you start having those architectures and implementations and requirements, you start to implement things like Kafka, Confluent, Solace, AsyncAPI, MQTT, webhook, WebSockets. It's a whole big world of different technologies and event brokers that help you with this journey to deliver on those use cases. Now, what we have been seeing is organizations starting to face the same type of challenges that the first generation of API platforms helped them with for their event APIs. So how do I productionize? How do I analyze? How do I centralize? How do I secure? How do I document my event APIs as well as my traditional, maybe REST and SOAP APIs? And this is where we believe that there's a new generation of API platforms that have a vision and strategy to deliver first-class capabilities also for event APIs when it comes to security, when it comes to protocol mediation, rate limiting, traffic shaping, regardless of you using REST, SOAP, async APIs, event APIs, GraphQL APIs, and so forth. So at Gravitee, we've coined the concept of event native API management. So what we mean by event native is the purpose of treating event APIs and event streams as a first-class citizen as far as a full lifecycle API management is concerned. So it means that you start really from the data plane and the fundamentals of a gateway architecture to ensure that your gateway is reactive, that not only can it take incoming requests and proxy to upstream services, but also it can actually listen to upstream services like a Kafka, like Solace, like a Confluent, like MQTT, and then take action, whether that is persisting a WebSocket connection, whether that is sending out webhook messages, and that it is natively understanding those protocols, that it can natively understand how Kafka operates, how MQTT operates, and so forth. We also mean providing native capabilities to event APIs when it comes to traffic shaping. So traditionally, organizations have been used to applying plugins or policies like rate limiting, transformations, and other type of logic transformations on request and responses of APIs. What we think with event native is bringing the same capabilities on the publish, so like producing, and the consumer and subscription phase of APIs. So that you can actually apply the same type of traffic shaping on individual messages on a stream. We also think it's important that organizations have a way to document and work with specifications that are native to event architectures, like AsyncAPI, like cloud events, for example. And we believe that API owners should have complete flexibility when they decide how they want to expose their APIs to end consumers. So beyond exposing things like REST and SOAP, we believe that event-native technologies have the ability to also expose Kafka, MQTT, and other common event type of architectures, but doing it in a way where the API consumer can be in control of an API producer can be in control of how those API experiences are being delivered. Am I delivering my Kafka as a REST API so that end consumers can register, get access, and use, for example, HTTP posts to ingest data into my Kafka? Do I allow HTTP GET using REST so that people can make long polling and retrieve data synchronously from my asynchronous Kafka cluster? Do I instead take an asynchronous approach? Maybe I document something using the AsyncAPI specification to say that I want to expose my Kafka or MQTT or Solace or whatever it might be using WebSockets, or maybe using server-sent events or webhooks. And again, provide that consistency in how the API consumers are discovering, viewing documentation, trying and getting access to those APIs. And that is what Gravitee believes is event native, and this is what Gravitee is delivering to our customers. So to introduce Gravitee, we are basically a full lifecycle management product. We cover everything from the design to the monitoring when your APIs have been developed. So we have an API designer. The API designer allows business users to use drag and drop type of technology to work with stakeholders in organization to document and design APIs before they even run. Then with a click of a button, you can mock your services on the gateway to allow your consumers and partners maybe to try out the APIs before you even write a single line of code. The API management product of Gravitee provides a gateway, so that's the runtime that helps you protect your REST APIs, SOAP APIs, Graph APIs, Kafka APIs, whatever it might be. We have a console that allows API administrators to come in and list APIs, provide access, define traffic shaping, security, and the entire lifecycle around APIs in a user interface, as well as a Kubernetes operator, ingress controller, and so forth to tailor all different administrators' requirements and how they want to work with APIs in their lifecycle. We have a documentation capability that allows you to work with OpenAPI, AsyncAPI, AskAdoc, Markdown, and so forth. And of course, we have a developer portal where people can produce APIs to set up categories, terms and conditions, onboard customers, have ratings of APIs, comments of APIs, and of course, the whole consumer and alerting experience on top of APIs as well. Gravitee also has an access management product that basically allows organizations to build secure experiences on top of APIs using things like OAuth 2, SAML. We provide multi-factor authentication, including intelligent multi-factor authentication to determine whether a user should have access to your API or not, depending on maybe if they did an impossible travel between the US and Europe in just 5 minutes, for example. It provides biometric authentication. So we have end users that allow people to authenticate to the APIs and get tokens, OAuth 2 tokens, for example, using their iris, the eye scan, the fingerprint scan, and so forth. And it allows you to federate across your Kerberos, your SAML, your Active Directory, and other types of services. We also have an alert engine product that allows API owners and producers to set up things like SLAs. So if you're having a sensitive consumer product that you're delivering, that you need to be notified, for example, if your APIs are responding slower than 50 milliseconds per second, or you're having a lot of error in the weekend, or whatever granular configuration you have set up, you might receive a Slack message, a team message, or other type of things. Alert Engine also allows your consumers to, in the developer portal, configure different health checks and alerts to say that I want to be notified if my end users' experiences that are consuming the APIs from this vendor is not up to what I have agreed with the vendor. And we have a cockpit solution that allows organizations to get a single pane of glass on top of all their Gravitee products, allow them to distribute traffic and deployments across organizations and environments and so forth. So I just walk you through a very quick example of what the user interface looks like in Gravitee. So this is the console of our API management product. So here I can come in and create a new API. So in this case, I'm calling this a real-time player analytics API that I want to create to expose my event broker topics to consumers using different types of protocols. So the first thing I decide here is whether I just want this API to proxy an upstream service without doing any mediation, without maybe working on event-driven messages. But in this case, I'm selecting message here to tell Gravitee that I probably want to expose something like a Kafka, but control how it is exposed in terms of the protocol. So in this case, I might be selecting HTTP GET, HTTP POST, service events, webhook, or WebSockets. I can actually select multiple of these entry points, and it's very compatible with an AsyncAPI specification as well as an OpenAPI. Once I've selected that, I can then decide what I want to expose. Do I want to expose something like MQTT, Kafka, Pulsar, Solace, different types of brokers? And again, if I would selecting the proxy option, I would have access to things like SOAP and REST and so forth. But in this particular case, I'm interested in exposing an event architecture using both synchronous and asynchronous communication protocols. So I might go through and select Kafka. When I do that, it will allow me to select my brokers, maybe my topics that again can be dynamically configured in the runtime, maybe the security of Kafka, maybe I'm using SSL Plain or Kerberos or whatever it might be using. So once you create your APIs, you have a lot of flexibility in terms of controlling how your APIs are exposed to consumers in a portal. What is the documentation like? What are the plans like? So planning Gravitee is effectively the contract between an API consumer and an API producer. It could be requiring you to accept terms and conditions. It can require you to provide an API key, maybe an OAuth2 token, maybe basic authentication. So that's what the plans do. You can then set up different API quality metrics to ensure that you're creating APIs that are consistent with the requirements in your organization. There's a bunch of settings around analytics and load balancing and so forth. One of the powerful things that Gravitee provides is the ability for me to provide what is policies on top of my APIs. So I can provide things like security, I can do transformations. In this case, I'm having an XML to JSON policy that automatically transfers a response from the upstream, in my case, Kafka, to JSON. And then I might transform headers before maybe I pass the response back to a webhook consumer, for example. So there's a lot of rich capabilities around security, transformation, routing, and so forth that you can set up with drag and drop, both for your traditional REST APIs and select them to be applying on things like post, get, put, delete requests, or you can do it on publish and subscribe in a event native world. This is an example of our developer portal that allows consumers to come in and discover APIs, to participate in rating and discovery and commenting on APIs. So this is where my API that I have exposed here gives a quick introduction to what it is. I can click it and see the documentation. Again, in this case, this is AsyncAPI, but that could be OpenAPI, Markdown, and other type of languages. I can then subscribe to my API to have maybe an API owner giving me access based on a particular plan, maybe a silver, gold, or diamond plan that is going to determine how many requests per second I can do, or what resources in the API I have access to. Now, one of the key things when you talk about monetizing and productionizing on your event APIs and maybe sometimes IoT streams is the requirement to ensure you have discoverability so the consumers can see in a consistent way both traditional APIs and your IoT and async APIs in a single catalog, self-service, try out, specification driven, and that your users can control how they want to consume your APIs. Do they want to consume them synchronously, maybe using REST on top of something like MQTT, or do they want to use something like WebSocket or AsyncAPI or whatever it might be to consume the APIs in an asynchronous fashion? Then, of course, you have to think about security, not only in terms of accepting applications to consume your APIs, but also how do you handle message level authentication? How do you handle threat detection? How do you handle alerting and analytics? How do you handle API keys and biometric authentication? And then you have to think about, how do I monetize on this? How can I, for example, control based on the body of different events that are streamed through, how I should be invoicing an end consumer or vendor based on that? And how can I build analytics reports and extract data into ERP systems to really generate revenue on top of what I'm building. So some of Gravity's customers are using Gravitee to drive these sort of transformations and new revenue streams. So we have one customer, for example, in the water and gas kind of industry that are using Gravitee to expose their IoT sensor information in various different shapes and formats using REST APIs, using Kafka, using MQTT. And what they benefit from is a single gateway in front of all the technologies that allows them to provide a consistent way of enforcing security, enforcing traffic shaping and topic routing and other types of logic on the runtime. And then obviously the ability to federate across multiple protocols. So maybe providing REST on top of Kafka, maybe providing WebSocket on top of MQTT and so forth. And for the consumers to be able to discover, view documentation, and try out and get access to APIs, regardless of them being asynchronous or synchronous. We have another customer that is in the sport industry that wants to provide real-time data tracking of player movements to their betting partners and other consumers. And they actually have embedded IoT sensors in the clothes of their athletes. And again, using the gateway, they can control the access to those data because they don't want to expose necessarily the event broker to their third-party consumers. They want to have control, maybe use OAuth 2, an approval experience, and all that on top of the data. And then they can, again, mediate across protocols. In their particular case, their end consumers are very much wanting to build web application on top of their player real-time data. So they use WebSocket on top of Kafka as a mediation implementation of their Gravitee gateway. And of course, again, they use the developer portal, just as the previous company, to expose that data in a self-service way to their end consumers that want to build experiences and applications and new revenue streams on top of the player data. And again, that they can choose the protocol that they would like to consume in. Maybe someone to use REST, maybe someone wants to use WebSockets, maybe someone wants to go directly to the Kafka broker if they have access to it. Coming back to one of the slides I had in the Gartner introduction, and some of the work that Paul has done is very much about allowing a single control plane to work with different types of gateways. I should stress that while the rest of the presentation so far has been capabilities and concepts that Gravitee already have and customers are running with, the next couple of slides is still roadmap items and prototype work in Gravitee. But it's really interesting stuff that we're doing, and I wanted to present it to you here today. So one of the things that we're working on internally is what we call the Discovery Center. And it's basically solving a couple of different use cases. So one use case we commonly get is, can I discover my APIs that run on other gateways, such as Amazon or Envoy, for example? So Gravitee today basically has a way to implement and import Amazon API gateways into Gravitee. And as a user, you can basically decide whether or not you want the APIs to be mediated and protected by the Gravitee gateway, or if you want to just use the API gateway from Amazon without having to use the gateway from Gravitee. And then Gravitee allows you to import those APIs automatically, and you can then effectively go and maybe manage API keys and the consumer experience, the documentation in a developer portal, but the runtime is managed by Amazon. It's a similar thing that we're doing with Envoy Gateway to allow Gravitee users to deploy their APIs to either Amazon, to Gravitee, or to the Envoy Gateway, which is typically the choice of service mesh implementations. Gravitee has a partnership with Solus, which is one of the leading event mesh and event broker technologies. And what we do here is we allow automatic import of Solus APIs that are typically described as Async APIs and event API products in Solus into Gravitee. And what we allow today is the ability for the Gravitee gateway to sit in front of a Solus event broker and providing protocol mediation, for example, exposing Solus events using REST, WebSocket, webhooks, server-sent events, and so forth with traffic shaping, topic routing, and other capabilities. And we're working on similar capabilities for Confluent but also with Solus and Confluent and other technologies, the ability to expose and generate event API products based on your existing event broker implementations, whether it's a cluster, topic, queue, whatever it is, onto the Gravitee developer portal and control plane without necessarily to having it being proxied by the Gravitee gateway. So that's all I had in terms of the presentation. Again, I appreciate that some of you would have liked hear directly from Paul. Hopefully I gave some of the Gartner research and the work that Paul has been doing. A fair presentation effectively. And I'll now go ahead and see my other screen here if we have some questions that are coming in. So there's quite a few questions coming in.
Yeah, we do.
Here.
Do you want me to read them out to you, Linus? I've noted them down on the side as well so that you didn't have to look at them. We've actually got a lot of questions to go through, and maybe I just pick up on two really easy ones to kind of get started. Firstly, we've had some great feedback on this webinar, so thank you very, very much. That's very kind of you. The first question was, a lot of people have been asking, have Gravitee got some sort of learning or certification problem? Yes, we do. It's relatively new. It was released about 3 weeks ago now. So go to gravitee.io/certification and you will find all of the information on that there. And I'll quickly just reiterate that this is recorded. The questions will be recorded as well. And everybody watching will have access to the recording tomorrow when I send it over. Now let's go to the questions that you're going to have to answer, Linus. So firstly, let's start here. Okay, so you covered this evolution of APIM and the move to async, but where do you see GraphQL fitting into this? And is this a technology we should be looking at? Some of these came quite early on these questions.
So GraphQL for Gravitee is definitely interesting. I think GraphQL is interesting in the way that it both tailors for synchronous API and asynchronous APIs. Now, what some organizations are doing is implementing GraphQL resolvers using things like Apollo and Azure and so forth, and want a better way to protect their APIs. And like API gateway is a perfect way for them to do so with things like rate limiting, complexity limiting, and so forth. Then you have some organizations that do not have GraphQL and would like to expose GraphQL consumption mechanisms to clients while keeping their REST or SOAP and Kafka implementations maybe intact. Now that is something that Gravitee is looking at and something that we think that we will be uniquely positioned to help solve effectively, as we do provide its protocol mediation and stitching of different synchronous and asynchronous services. So GraphQL is definitely interesting in the sense that it provides the query and mutation capability for synchronous APIs and subscriptions for asynchronous APIs. I hope that gave some type of cover to that question. I could probably speak for 2 or 3 hours on GraphQL, but whoever asked that question, I'm very happy to dive deeper into it. But I appreciate we probably have quite a few questions and not too much time left on the webinar. So I'll pause there, Jordi, for that answer.
Thanks, Linus. So the next question has actually got a few parts to it. So I'll try my best to read it out slowly. So we have an existing investment in an APIM vendor, but they don't handle the asynchronous use case. I'm assuming that Gravitee could work side by side with another APIM vendor. Question. But what about presenting a consolidated developer portal to the end user? We are reluctant to have multiple portals as that could be confusing to the end user.
Yep, that's a very good point. And the way I see it, there's basically 3 solutions to that problem. One is, of course, that you go and pursue a developer portal that provides you the ability to integrate across multiple types of API gateways. Now, typically that is quite a cost-heavy implementation. It's something that you have to maintain yourself, but it's definitely an option. Another option, of course, is to mediate and proxy all your API gateways that you currently have with a single API gateway, because that provides you a single set of security capabilities, traffic shaping capabilities, and so forth, and allows you to have a single developer portal that fronts the API gateway for one of the vendors that you have. The drawback, of course, with that option is that from an architecture perspective, you're basically adding an infrastructure hub on top of some of your existing gateways. The third option, of course, is to look at a single control plane managing API keys, documentation, and security, and so forth on top of multiple vendors. So that's an area that Gravitee, among other vendors, are looking at and playing around with. So as I mentioned, we currently have prototypes for doing exactly that with Amazon and Envoy. So I don't think there's a silver bullet to answer that question. There's a couple of options in the market to allow you to take different approaches, whether it's using a single developer portal provided by a third party to consolidate, whether it's using a single gateway on top of multiple deployments to consolidate, or whether it's using a single control plane that allows you to manage some of the lifecycle aspects of your different distributions.
Awesome, thank you. The questions are coming in thick and fast, so I really appreciate that everybody is sending them, but we may not have time to get through them all. Next question, can you speak to some of the challenges we should be thinking about when it comes to trying to monetize asynchronous APIs?
It's a very good question. I think traditionally with synchronous APIs, from a monetization perspective, what you typically care about is three things. So one, should you be charging for a particular API call? Because that might have an impact on whether or not your API consumer got maybe a 200 OK response, for example, or whether there was some more logic, maybe a transaction was not completed, then maybe you shouldn't be paying as an end consumer for it, right? So you need to have, for traditional APIs, a logic in place to look at and evaluate whether or not you should be invoicing. Now, what I would say is that traditionally API monetization and invoicing capabilities are very focused on request and responses, and are not able to understand individual messages or rate of messages that happens on an event stream. And I think that's where it technically is a little bit different, and you have to ensure that you work with technologies that are able to analyze and report not only on request and response communication, but also individually stream messaged in a persistent connection, for example. And ability, of course, to extract maybe payload information to make analysis whether or not a particular message potentially should be billable or not. So definitely some more things to think about there, and making sure that you have an invoicing and analytics and message level compatible solution to help you deliver monetization on your event streams and your event APIs.
Amazing, thank you. Next one then, a question that came actually relatively early on, which you kind of answered, but we'll just reiterate it anyway. So we utilize Solus as our evented backend. Can Gravitee work with that?
Yes, for sure. So we do have an official strategic partnership with Solus, and there's basically two modes of operations that we deliver on top of Solus. So the furthest that we have in the development is the ability for Gravity's gateway to sit in front of Solus. So as a Solus event API owner that works in the Solus event portal, you can go in and create events and event APIs and event API products in Solus, and then just tie those event API products with Gravitee. Gravitee is automatically exporting them into Gravitee, deploying them to the gateway, providing protocol mediation like REST, SOAP, whatever it might be, WebSocket, webhooks on top of Solus Event Broker, and then also allow the API owners to do things like topic routing and OAuth 2 security, exposing to a developer portal, and so forth. What we're also working on, and we're still in the prototype and early stages on that with Solus, is the ability for Gravitee to import event API products from Solus, but not having our gateway sitting in front of them, meaning that they're exposed to the developer portal, the documentation is there, just as in my previous examples, but when someone is subscribing to that API and gets approved, the federated security is pushed to Solus Event Broker, and the consumer is then, in that case, calling the event broker for Solus directly without federating on top of Gravitee. And that is for use cases where you don't want or need any protocol mediation. You want to use Solus protocols like AMQP, MQTT, SNF, and so forth, but you still want a self-service and developer-friendly consumption and access model.
Awesome. The next question, I'm actually going to jump to this one because it is related to a question that you already answered. So what if we already have an APIM and we just need your API developer portal and API specification builder capabilities only?
Yes, Very good question. So for the API specification builder, or the API designer, as we call it, I'm going to be completely honest here. We do have customers that are not using the Gravitee gateway or the console, but are using our API designer to allow their business teams to run and build API models using drag and drop. But then what they do is they just simply click the export button and they move that into other third-party API systems like Apigee, MuleSoft, and so forth. So that exists. I'm going to be honest with you. In terms of the developer portal, traditionally with Gravitee, it's technically not something that we have supported, but we're now adding support with in terms of AWS and Envoy as the first solutions that Gravitee allows you to expose and manage APIs on a developer portal without having Gravitee operating the runtime. So it's something that we're prototyping and building out, but not something that traditionally Gravitee has had a capability to do. So to reiterate, for API design, absolutely, customers can use and do use API Designer for Gravitee, but maybe using a competitive API gateway and management solution of Gravitee for the rest of the lifecycle. And for the developer portal, traditionally not, but something that Gravitee is maturing and growing into to allow consumers and customers to discover and work with APIs that sit on other technologies than Gravitee Gateway.
Listen. Right, we'll move on to the next one. So we are a fleet management company and we use Gravitee as the API management, and we want to move to async using RabbitMQ. Is it possible for Gravitee to create a tutorial for us with RabbitMQ or MQTT or Kafka in order to implement async API calls?
Yeah, absolutely. So I think there's a couple of different answers to that. So we obviously provide the documentation. I know some of our teams are currently revamping the entire documentation, so stay tuned for that. But there's definitely some examples. We have a big Postman collection. We have tutorials on how to run these sort of mediation, specifically on MQTT and Kafka. RabbitMQ and MQTT is something that is coming very shortly in terms of a technology. We then obviously have a consulting and solutions engineering customer success, because I think, George, you mentioned that this is an existing customer. But we would definitely be obviously very happy to work with you to ensure that we are able to hold your hand and point you to the right set of resources to ensure you get started with your protocol mediation and exposing those sort of events with Gravitee.
Amazing. Gosh, I feel like I've never talked so quickly in my life. We've got a couple more. Let's fly through them because I think we've just about got enough time. So are there performance benchmarks available for latency and or transaction/sec with infrastructure requirements?
Yeah, that's a very, very good question. So publicly at the moment, we do not have performance metrics available for asynchronous use cases. We do have that inside Gravitee, for example, a payload size implication on and consumer implication of running things like webhook on top of Kafka. It is something that we're implementing testing strategies around to ensure we do not have any degradation. We do have internal metrics to share as well, but at this moment of time, we do not have that publicly. So Georgia, whoever asked that question, I very much welcome reaching out privately to me, and we'd be happy to share both the use cases that we're testing on, as well as the testing strategy of Gravitee when it comes to performance across the different releases that we do.
Yeah, that's a good idea. I'll pop your details to that person. Would you consider it a best practice to pick one protocol when exposing async APIs to an external party?
That's a very good question. So I'm going to be honest. So we do track what our consumers and customers are preferring. I'd say that for a number one consumption model, it's a split very, very evenly between REST and webhook as of this very moment in time. So for Gravitee customers, REST and webhook is the most used protocols on top of event-driven architectures. The third option is WebSockets, then followed by servers and events. And then we have customers also asking for natively consuming protocols using Kafka and TCP directly on a gateway. But that's kind of the order. It goes REST/webhook, then it goes WebSocket and servers and events. Now, it really, really, really depends on your consumers. What is the technology maturity? What is the security principle that they have? We have some customers that are deciding, for example, to expose Kafka with both REST and REST and webhook and WebSockets, for example, and really give it up to the consumer to control how their application is best operating. Because some consumers might say, well, my server is available at any given time, just push me messages using webhook capability whenever there's a change in Kafka, for example. And that's typically the kind of server-side type of use cases. Then we have a lot of B2C use cases. For example, the example I presented, where people want to build real-time experiences in mobile and web applications. And then you're typically talking with things like WebSockets and services events on top of your Kafka and MQTT and so forth to deliver those capabilities. And then you have some clients that are maybe waking up every 5 hours and want to make a GET call to retrieve all the latest messages in a Kafka topic since they last fell asleep, for example, maybe because they're sitting in a bus on a highway somewhere and they're not able to talk to a broker or a gateway very often. So it really, really depends on what your consumers and applications require. And that's something where it's very beautiful in Gravitee, where you have the ability to select one backend and expose it with multiple entry points in one single API.
Cool. Thank you. Just a few more left now. So how does Gravitee work with middleware/iPaaS solutions that are responsible for connecting apps using a mix of protocols?
Very good question. So some customers, I'm going to be honest again, almost use Gravitee as an integration tool for a lot of calling out to other services, stitching services together, doing transformations and so forth. It's not necessarily the intention of Gravitee to be an integration tool. But we do obviously have a lot of capabilities that have helped customers deliver on a solid integration use cases. But that's not where, as a vision, Gravitee is intending to play. A lot of our customers are using technologies like SnapLogic, like Boomi, Talent, and other services for ETL, ELT, and iPaaS type of use cases. And if you're having a very mature integration plate and you have an iPaaS in your toolkit, it's fairly common that Gravitee is then proxying that integration middleware effectively. Now, some integration vendors have things like MQTT, AMQP, Kafka, and so forth, connectors to allow you to ingest and egress messages out of that. What is very uncommon that they have is the ability to expose those. Quite often you can using REST, but it's very rare that you can expose or produce into event brokers and other event kind of capabilities in an iPaaS using WebSocket, using webhooks, using service and events and those type of technologies. And it's very rare that you have a self-service developer experience on top of it. And I think that's where something like Gravitee can sit on top of an iPaaS or integration middleware to help deliver that protocol mediation and self-service consumer experience on top of your middleware.
Amazing. I think we've just about run out of time there, Linus. So there are a couple more questions and I will make sure that they are answered by email. Thank you to everybody who has attended today. It's been great. And we've had some super feedback. So despite it not exactly going to plan, it's definitely been worth it. So thank you, Linus, for your time today.
Thanks everyone for attending, and look forward to any follow-ups and questions to help you guys get going and answer anything around Gravitee. Thanks for listening in.
Thanks. Bye, everyone.